Now, the next item that I want to talk about is using surfacing to help clean up complex junctions of faces, or in this case, I'm going to do a fillet section. So for example, when we have a fillet or a grouping of fillet, this has like 5 or 6 or 7 different fillets that intersect at a single location. That location inherently ends up being a little bit messy. And we have an extra face. This actually goes to a little point that can be problematic. So I'm going to use some surfacing tools to kind of trim it away and make it a little bit more streamlined without all of the extra small faces, something that would be a little bit more intuitively like a fillet. So I'm going to go ahead and close this. I'll save it. And let me open up the next file. So now if I look at this, this kind of grouping of fillets is in 4 places. I don't want to have to do this 4 times. When you start working with surfacing, definitely take a look at the type of symmetry that's in your model, because surfacing is like building something almost face by face. So you don't really want to have to do this a lot of times repeatedly. So I'm going to split this model into 4 sections, and I'm just going to keep the 1 section. I will eventually mirror it at the end. I wanted to do that the opposite of what I just did. Yeah, there we go. And so I'm still in a solid body. I just split the solid into a smaller solid. So what I'm going to do, so I can use surfacing tools, is I, again, am going to use delete face, and I'm going to delete some of the faces that I know are bad. Now, I also want to delete the top of this face, but I don't want to delete the whole thing. This whole face goes all the way down to the bottom, and I don't need to delete the whole thing because that's just a lot more work to try to recreate something that is actually fine. So what I'm going to do is I'm going to create another plane that's right at that point, and then I need a second reference here from my top plane. And then similar to what I did in the previous example is if you go into a 3D sketch, use the intersection curve, you can use a plane and just this one curved filleted edge, and you get a kind of perfectly fitting spline arc curve exactly where that plane is going to be. Now I'm also going to use convert entities, and it does convert the whole line, but in a 3D sketch, I can still remove that section. So I'm basically creating almost like a trim tool for myself. So when I go into my surfaces tab, I can start using my trims. So in surfacing, we don't like cut stuff. The way we cut a solid, we trim surfaces. Just a little bit change in terminology there. So here I can choose to remove this section in purple. So now I'm left with like a nice kind of hole that I can then recreate what I need. Now, just because you're using surfacing doesn't mean you can't use 2D sketches. I use 2D sketches whenever I can because they are typically much easier to create. So this face is flat. I'm kind of looking at this at an angle, and I'm going to use a spline. There's 2 main types of splines. The first spline is just the old school regular spline where we're going to click on every intermediate point, and SolidWorks creates like a continuously curved item through all those points. There is a style spline that's a little bit different, where instead of choosing all the intermediate points, you actually control the polygon surrounding the spline. So I'm going to choose my regular spline tool. And when you work with splines in SolidWorks, try to use the least number of points possible because your curve ends up being much smoother and a lot less error prone. So here, this is a spline, but it looks like a line. It's not though. If I were to click on the spline, I would get my handles. So I could start moving this. I can change kind of how this is going to look, move it around. I still make use of sketch relations. So I can add sketch relations like vertical to the handle itself. And I can also add sketch relations from the open edge to the spline. And we have some specific ones for kind of these 3-dimensional spline features. And this one is going to be like continuously curved. So what this is doing is it's taking the curvature of this edge and continuing it perfectly smooth until it goes down. Now, I am not going to exit my sketch. Some people exit their sketch all the time, but if you don't in surfacing, if you go into trim surface, it automatically grabs that sketch as your trim tool. Just a couple less clicks for you. But that creates a nice kind of open section there. Now here, this is actually a point. That was the point that I pointed out earlier. So that's going to create an additional seam if we don't take care of it, because remember I mentioned that's what points do. It's going to try to go to a point, and then how those faces get generated, you're going to end up with an extra line. So again, I go into a 3D sketch. I'm going to use just another 2-point spline. And you can utilize sketch relations like tangent is usually all that we need in order to grab some of this information. And I can move this as needed, make sure it's not overlapping. And again, we can trim this out. Now this is a really detailed, this is a tiny detailed small little thing, but it can have a really big difference because we actually didn't want it to go to a point here. So if I remove that, I now have a much better curved section. I'm going to do one more spline from here to here because if we look at this edge and this edge, it would make sense. You would normally have something there. You can't get away from 100% of the lines, but we can certainly clean them up. So again, using 2-point splines, again, kind of a little trick that I think is underutilized. People think that you have to have just tons of little points to work with splines. And honestly, if you leave it to the least amount of points as possible, you get a much better curve. So now that I'm here, I can actually go back into my surfaces tab, and I tend to use boundary surfaces, usually over lofts. There's such a subtle difference there. A lot of people don't realize actually what the difference is. The main difference is that in a boundary surface or a boundary feature, direction 1 and direction 2 are calculated simultaneously. One is not given a precedence over the other. So direction 1 and direction 2 have the same precedence. In a loft, direction 1 or your profiles are calculated first and your guide curves are secondary. That's why you end up with a slight difference in geometry between the two, but they're very, very close. So here I'm still using my selection manager, and I did not necessarily use the fit spline for this, although I could have. So I'm going to choose my groups here. So we can see how that's being created. And then under direction 2, I'm grabbing both of these open sections and then doing the same thing here and here. Now we do expect there to be one line in the middle because of the inflection point down here. There's actually a change in direction from here and here. And so there is going to be one line in the middle because of that point. So that is what we expect it to be. But again, it creates a much kind of cleaner section than what we started with. So again, from here, I'll go ahead and choose my 2 surfaces. Make sure you choose create solid. And then the only thing that I have left to do is I'm going to remirror these because remember I split them at the beginning because I try not to do things twice if I don't have to, much less 4 times if I don't have to. Just be careful. SolidWorks in these later versions are what I call more sticky. Drives me crazy because I didn't want this to be under features to mirror. There's not a setting for that. You just have to, I guess, not be annoyed. I don't know. Just deal with it is kind of, I guess, the mentality there. But now I have all 4 of those fillets that have been kind of propagated to each side. And I was able to kind of clean that up from its original state. So definitely looks much better than what we had. So what we also covered in the first 2 examples is also common steps that you can use on step files, IGES files, parasolid files, generic files. This is almost identical to what we call direct editing. So you are removing faces and replacing them. So everything we're doing here also applies to generic file types. Fillets are notoriously bad as far as how they're translated between CAD systems. That's not a SolidWorks thing, that's just a CAD file thing. They're algorithmically much different between CAD systems. So fixing fillets in imported files tends to be a somewhat common thing that happens.